Make it in America. Today we're going to talk about what we do to produce our products right here in the USA and how you also can use this awesome technology that makes it smooth, easy, and efficient to produce hyper complex or even simple parts with 3D printing right here today. Okay, so you probably know us as the high temp printer guys, right? We've been reselling high temperature 3D printers for Peak and Ulta for the last almost 10 years. But on top of that, we sell 3D scanners, a full line from hobbyist all the way to the six-figure metrology inspection devices. And we also resell Formlabs. Now, Formlabs is an American company that specializes in printers that just work in SLA, liquid photopolymers, and SLS, which is the powder that gets hit by a laser to build your part. So today I'm actually going to walk you through the entire process, show you exactly what it takes to print thousands of parts overnight for our high temperature 3D printer. Let's get right into it. Okay guys, we're here in the Formlabs room here at Vision Miner, and of course we do sell all the liquid photopolymer resin stuff. Really cool part in there that it's going to be in a video soon for a big YouTuber, Alan Pan. But we sell and use this stuff every single day, as well as all the SLS equipment. So the Fuse 1, the Sift, the Blast, all an incredible ecosystem. I seriously cannot, stupidly easy to use. And when you use it, basically inside here is the build chamber right in there. We've got a fresh print ready to pull out and show you how it's done. You end up with just block of a whole bunch of stuff, and then so you go in there with the brushes and everything, you get a lot of that loose powder off in the Sift, and then you reclaim all that powder. And then the powder that's really close to the part is actually slightly degraded, so you don't actually want to reuse that. So you just do a light brush job, get all the loose powder off, reclaim that powder, throw these into the blast, and then you get parts like this. We have the polishing system installed, so it's hitting them with the beads and the air, and then it hits it with a little bit of the polishing liquid, which just smooths out and seals the outer surface of the parts. There's a lot of empty space in there, right? This is gonna be packed tightly, so we filled it with a boatload of other tiny parts that we were producing in FDM or other methods, and now we just make them all at once. With tiny parts like this, we're packing the build volume so densely that we're doing like an 80% refresh rate. We're supposed to do a 20% fresh powder, 80% reclaimed powder. We're being so efficient, we don't have that much reclaimed powder. It's kind of crazy. First things first, really easy, we're just gonna open the machine. And then we see our chamber. Open that, pull this out, and then make sure that the Sift is open like that. I'm gonna turn it on real quick so we got some light. And then you just take this, slide it right in there, lock it in, and then we're gonna get this plug down here as well. We'll take that cover off. So now, slide that back. I'm gonna go over to the controller here. The chamber is ready. It tells me the temperature, so I know that it's cooled down enough. You can hot swap the chambers, but you do want them to cool down, and this one's still kind of warm. So I'm just gonna hit up, and here we have the print rises. So we've got our entire cake here. Ah yeah, nice and warm. So I'm just gonna bring it over. I'm gonna start the Sift right here, the Sift button, and then just sort of move it around. Roll it up and down, roll it around, and then I can take this and I could start brushing it off a little bit. One of the things I love about this unit is just how well it contains the powder. Like, look at that. It's all sucking right back in there. Yeah, it's definitely still really warm in the middle. If it's too hot, what you can experience is warping during the cooling process. So that's why you want to leave it until it's below a certain temperature. Okay, so it stopped sifting because the Sift hopper is full. So I'm actually going to go over here, and this little thing right here is the mixer. So this is already mixed and ready to go. So I'm going to open the top here, and then take that, throw it on top, and then just open the slot. Give it some knocks, and then you really want to let it sit so that, you know, when I close this, I don't want a bunch of plume of dust coming out. close that again since we're in production mode. All right, there we go. Just close that and then take this thing right back down into this drawer right here. Bing, bada boom. There. Now, since it's, we're gonna abort the sift, and then we're gonna go, we have 1 kilogram of loaded powder. We're gonna go down to a 20% refresh rate. I'm surprised this screen still works pretty well, even though it's covered in powder. Okay, that should be good. Fill. We're gonna continue. Sift hopper full. Yep. Why is the past sifted powder hopper low? It said it was full. We're gonna continue. Something's wrong, dude. Okay, so it turns out that error that we were getting that the hopper was full is super easy to fix. It's actually an error. So we'll go in here, I'll just show you real fast exactly how this works. All you gotta do is take this, open that up, and then you just flick these to the side. Super easy, boom, take out the sift, and then right down in there, you'll see we've got these optical sensors. We've been using this machine so much over the past few months that those sensors actually got just too much powder on them, and they're designed to not have powder stick to them. So we just went in there with some of the ethanol alcohol. This is a cool little thing. Take a little paper towel, whoop, whoop, and then wipe them off, reinstall everything, and keep going. No big deal. Again, just a testament to the design and maintainability of Formlabs products. Another reason we sell what they offer. All right, and we're back in business. It's kind of a Zen sort of thing. It's like being an archaeologist. It reminds me of back in the early 90s when the first time I saw Jurassic Park. Literally just like that. Childhood dream coming alive right here, right now. And it's something that you can, anybody can do. So if you want cheap labor, just hire the community college students that want to get into additive manufacturing. It's a great thing for interns to do. Speaking of interns, I'm actually gonna have the interns finish this. So basically all we have left to do is take the parts that we've depowdered with still a little bit of powder on them and toss them in here. This is the fuse blast. Now this wheel rotates constantly around while it's being sandblasted. We actually have the bead blast going on here. So you get the compressed air, the beads, and then this unit over here actually is taking and spraying a tiny little bit of polish at the very end of the blast. So this gets all the extra powder and everything off. Let me just throw some of these in there. And you can also remove this entire thing and use it with gloves. So if you want to turn this cabinet into just a regular sandblasting cabinet, that is an option. And it gives you all these options to change settings and do different amounts of time. So based on your part size, you can make it go lower RPMs if you got big parts in there, or faster if you want. It's been absolutely fantastic having this unit just for all the post-processing. We used to manually sandblast everything and it was a freaking bear, dude. So literally having this thing, a godsend. Fantastic. And your parts come straight out of there with the polishing unit, and they come out absolutely beautiful and ready to go straight into service just like this. If you're interested in a system, an SLS system, or a liquid photopolymer resin system, we've got it here at Vision Miner, and we use them every day so that when you give us a phone call, we can actually help you figure out if something's going wrong or get the new stuff that you need. Our company is founded on support and consulting companies to get the right equipment for what you're doing in your business. So give us a call, shoot us an email. We're here to help. But now let's go check out some of these parts. And let me explain what each one is for. All right, so now that you've seen the process, let's show you what we've actually done with it and what type of parts we're putting on our 22 that if you bought one of those, you would see. Let's start with these very simple parts here. These are just little simple covers for the fume extraction ports. So we also have the plenums which replace these. So this is a flat cap, but we also produce the parts that connect to the plenum, and we actually do those on the 22. So we print those in carbon fiber nylon in FDM because it's a bigger, bulkier part. It's a little more efficient, And we've been doing that for years. So these are just caps that cover the holes in the back of the machine. So these here are spacers that go in between the spool rack, the rack that holds the spool, and the stainless steel interior. So one of the little things we discovered very early on was that the screw placement of the stainless steel interior on the early batches was in a place that could catch on certain spools of filament. So basically you'd be like, why is it air printing? Why is it clogged? And then you test it, nothing's clogged, and we found there was actually a screw that was catching on the spools. So for those early versions, we created this part. Now this is the second revision. This was actually the first revision, just a very simple puck that spaces the spool out from the wall so it can't catch on that little screw. Now this one has this little lip here so we can actually screw it down and secure it to the filament holder. So rapid iteration, very cool. This part right here, very simple part. This is actually one of the little holders for the glass on the front door. So this just holds the glass in place. It's a spacer that just keeps it perfectly spaced, and it just sits right in there. It's got two little screw holes on the bottom. So cool little part. The next part we have is actually a bracket that holds the chain in place, the wire chain for the Z-axis. It's that bed that we have that undulates like this for 5-axis printing, goes to 200 Celsius. This part just sits right in there and is the connector to hold the cable chain in place. These little parts actually just hold the LEDs inside the chamber. So this is a little peg for alignment, and then there's a screw that goes in there, and then the LED strip just clips right in there. These parts actually hold the terminal block on top of the extruders and hot ends. So this is where all the wires plug into. The terminal block just slides right in there, and that's its mount. Now, we've got this little lip going on right here, and if you'll notice, this is the original part. Now what that does is as the extruder is moving around and everything, sometimes it'll come close to the edge or over next to the other, or the wire chain or things like that. So this little lip just allows it to have a little buffer zone and smoothly glide past anything. Next, we have these parts. Now, these two parts, very simple. They're just brackets. They're alignment brackets for the top door lid hinges. So these parts just sit right here like this. They keep everything in the right spot and hold the hinges in place that connect to the lid, open the lid. Moving right along, we've got mirrored parts. So these are actually the hot end wire guards. So these are the little parts that basically go onto the side of the machine. You've got these little wires coming up from the hot end that melts all the filament, and it goes up to the terminal block. Now this little guard just basically keeps all those wires nice and contained and out of the way, and they're not going to catch on anything. And these just mount right there via two screws right there, and keeps everything tight and protected. Now you're probably going to notice a little bit of stair stepping. These two parts were printed at different orientations. Now if I show you the back, you can really see that contrast. You see all those little stair steps? And that means that this part was printed flat like this, but at a slight angle. Now, a lot of times, I swear, the Form Labs are so easy. Their whole goal is one-click print. Just throw it in and it'll work. That's their goal with all their machines, and we love them because we use it all the time. If you go back and watch the first look video about a year ago when we first got all these machines in, and I set up the print and I just say, okay, one click, and I was blown away how well it worked and how perfectly the parts came out. But if you have certain parts like this, you might want to lock the orientation if you're worried about the surface finish having any kind of stair stepping on it. For these parts, does it matter? No. Still going to be strong, still going to be capable, still going to do everything, but this is one thing that we do go through and say, all right, well, cool little example there. Moving right along, we got a couple more versions of a part that we're no longer using. And this little guy, actually, no, we'll start with this one. This was designed to clip onto the wire chain and hold the PTFE tubing that feeds the filament from the spool into the hot end. So you have this little part here that actually rotates, and this is all printed in place. This was printed in one piece and was not assembled. I don't know if you can see that on camera, but it rotates. I mean, no assembly required, and this thing would just clip straight on. Now, we updated that and switched it to a new version, and a much more simpler, smaller version, and same rotating feature with that. Basically, this one just clips on the side the same way, but it's much more minimal, right? See how much less material's there? It's just a smaller part. Now, these ones didn't work that well either. They kept falling off, so we're still working on a new version of that may be revealed on a future version of the machine. Or it'll just be released, and we'll send an email to all our customers and say, hey, we got new parts for you. Actually, that's an interesting point. Currently, we're using zip ties, which are reliable, cheap, consistent, work well, don't fail often, if ever. So this part could be considered like overkill. Like, do we need it? No. Actually, there's a very well proven thing that works great, but it doesn't look as professional. It's not as dialed in and tuned up and designed and customized and everything. So you always got to weigh those options, right? Are we going to make a version of this part that works perfectly the way we want it to? I don't know. That has yet to be seen. Do the zip ties work perfectly? Absolutely. So something to consider. Next, we've got the Y-axis end stops. So these have a little, these basically clip in. There's little wire clips here that hold the wires, and then the micro switch actually connects to this little surface right here. And then these have nuts that you put in there. You just sink two little nuts in there, and then that mounts, and you screw in from the other side. So this just holds the little Y-axis end stop. And then, of course, the X-axis end stop. We've got another one right here, and the micro switch, as you can see, just screws into those two little holes right there. This sits on the top in the back of the machine, and then we sink a couple screws right there and there. Actually, I think it goes upside down like that, so it's covering the actual micro switch that comes out here. Screw it down, boom, just a nice little housing. Is it necessary? No. Does it make the whole thing more refined and nicer? Yeah. Is the plastic ever gonna fail? No, probably not. So, great part, very small. Over here, we have these, tiny little two parts. They sit like that. And these actually hold the ball on the Z-axis shuttles. So these hold part of that bracket on the Z-axis to move the whole machine like that. This little part is actually a nut holder. This you put your two little nuts in there, and then you hold this up against the door, and you install the door hinges. So this actually does stay on the machine, on the outside of the machine, and it just makes it easier to assemble. And finally, this is the original reason we switched over to SLS. We wanted a beautiful shroud enclosure for the touchscreen on the front of the machine. And we could do that in FDM, no problem, very simple part, just print it flat on the bed right there. But the problem with that is the bottom surface, you're gonna see all the layer lines, all the extrusions, which isn't a bad thing, but it's not the prettiest, most refined. And if you're printing flat on the bed, then you have to space them out, and you can print like 6, maybe 8 at a time. Whereas in SLS, we can pack the build volume full of these, as much as they'll go, and then, you got a bunch of open space in there, right? That's as much as you're getting. That's as tight as you can pack these parts, right? So what do we do with the space inside? We fill it with tiny parts. So if we just needed these, it might not be the most efficient process, not the most efficient way to produce the parts. Probably stick with FDM at that point, or just go full injection mold. But the fact that we use all these, we can use all these parts, we have all these parts, and we can fill all the tiny little gaps and holes with these tiny parts, it made it a no-brainer to completely pack the build volume. To give you an example of how packed we're packing the build volume, we don't have enough sifted powder to mix with the fresh powder. You're supposed to do a 20% refresh rate. We're doing more like an 80% fresh powder rate because the pack volume is so efficient that we don't have enough sifted spent powder that was just floating around in here to do the 20% refresh rate. So incredibly efficient. We're basically losing next to no powder, just using more and more fresh powder, which is fascinating. So these are a bunch of the parts that we're producing on the Fuse 1 Plus from Formlabs, which we do sell on our website at visionminer.com, along with their SLA liquid photopolymer resins. Very cool stuff, amazing, robust, tough materials, truly industrial materials from Formlabs on the SLA side and the SLS side, along with our 22 IDEX, our flagship printer for high temperature materials like PEEK and Ultim and all that. The V4 is out and in stock and shipping, and these are some of the parts that we produce right here in America for our machine. We also make nanopolymer adhesive, which is a bill plate glue designed for high temperature materials, but it works for everything else too. So don't take my word for it, just go Google the reviews and you will be amazed. I'm still amazed. Anyway, thank you guys so much for watching. What would you make? Leave it in the comments down below. What would you love to produce in SLS? Other than that, have a positive rest of your day. Thank you so much for watching, and I'll see you on the next video.